Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of climatology. We are discussing Koppens climate classification, and this particular video lecture 1C is the continuation video lecture on the topic of Koppens climate classification. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM PG, Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Before starting this particular video lecture, let me just give you an overview of what we did in the previous video lectures regarding the Koppen scheme of climate classification. So we have already covered all the major climate subtypes under the Koppen scheme. So A type of climate and B type of climate was discussed in video lecture 1A, and C, D and E, all these three were discussed in video lecture 1B along with the H type of category or H type of climate. So we've already discussed all the subcategories. In this particular video lecture, we will be discussing in totality the Koppen scheme with all the climate subtypes in a global perspective. So we will discuss each climate types, its overview, its prevalence on world map. In this particular video, the main objective will be to present an overview of Koppen's climate classification scheme on world map, presenting all the climate categories in totality together. And then we'll be evaluating the Koppen's climate classification scheme and presenting the merits and demerits of Koppen's scheme. And finally, we'll be discussing few modifications which were given later on to the Koppen climatic classification scheme, and what are the other important climate classification schemes besides the Koppen's climate classification, just like the Thornthwaite climate classification and the one given by Trewartha also. So we will be briefly looking into these two schemes given by Thornthwaite and Trewartha and how the Koppen's climate classification is different or related to both these schemes. So let's begin. Let's just quickly see Koppen's scheme of climate classification in the world map altogether. So along the equatorial areas and between the tropics, you will have A type of climate. A type of climate resembles the tropical type of climate. So definitely along the equatorial areas, you will have more rainfall. So you will have evergreen type of climate or AF type of climate. And as you will move from the equator towards the tropical areas, you will have variants of A type of climate, for example, AM type of climate, AW type of climate. So here you can see that along the eastern margins, you will have AM type of climate in the tropical areas, and towards much more interiors, continental interiors, you will have AW type of climate, or you can say Sudan type of climate. So continental interiors will have AW type of climate. Towards the wetter eastern margins, you will have the AM type of climate in the tropical areas. So these are all the variants of A type of climate, which is found between 10 to 30 degree latitudes in both the hemispheres. Then between 10 to 30 degrees only along the subtropical belt or the drier margins, you will have the hot desert type of climate or B type of climate. Okay, so towards more continental interiors along the tropical areas where rainfall is not that sufficient, you will have B type of climate, okay, along the subtropical belt in both the hemisphere. Okay, so along the drier margins, you will have desert, but when you will transition from AW, that is savanna type of climate, towards the desert, somewhere in between, you will have tropical grasslands also, or BS type of climate also you will have somewhere in between. And similarly, in the temperate regions along the continental interiors, you will have the cold deserts. Okay, so they also form part of B type of climate. Then again, when you move from 30 to 45-degree latitude, this particular area is dominated by C type of climate. Okay, so along the eastern and western margins of this belt, you will have variants of C type of climate. So here you will have Mediterranean type of climate along the western margins, or CS type of climate will be found along the western margins. Okay, and other variants of C type of climate like CF will be found along the eastern side. So CF type of climate or CW type of climate like China type of climate will be found along the eastern margins of the continent. So variants of C type of climate will be found in the belt extending between 30 to 45-degree latitudes in both the hemisphere. From 45 to 65-degree latitudes, particularly in the northern hemisphere, you will have the D type of climate. Okay, so variants of D will be found along this particular region, and this particular region, D type of climate, is generally found along the continental interiors because these regions become extremely cold during the winter time period. And D type of climate is seldom found in the southern hemisphere because of non-existence of land in the southern hemisphere beyond 60-degree latitudes. So you will have cool temperate zones in these particular areas, and you will have rainfall throughout the year. Specifically in the central regions, you will have Siberia type of climate, which is represented by DFD and DW type of climate. And then along the eastern and western margins, you will have British type of climate along the western margins and Laurentian type of climate along the eastern margins in D category in the northern hemisphere. So you'll have Laurentian type of climate here, and then you will have British type of climate which will be experienced here. And then beyond 65-degree latitude, you will have first ET type of climate, okay, and then you will have EF type of climate. So the central Greenland region is entirely EF type of climate, and the Arctic region of the northern hemisphere and Antarctic region of the southern hemisphere will also have EF type of climate. While along the margins of EF type of climate, you will have certain time periods of the year where snow will melt. So it will be dominated by ET type of climate, and the entire region will be under the permafrost. So if you consider the vegetation, you will understand that A type of climate mostly have evergreen type of vegetation, and then as you transitions towards the tropical areas, the amount of precipitation reduces. So the evergreen forest transitions to deciduous or mixed type of forest or monsoon type of vegetation. And as the precipitation reduces further, you will have savanna type of climate with scatters trees here and there and grassland type of vegetation. And then gradually it will transition to desert type of climate where you will have xerophytic vegetation. C type of climate is also dominated by mixed forest. Towards the tropical areas, you will have more deciduous type of forest, and towards the temperate regions, you will have more evergreen type of forest. And D type of region is dominated by boreal forest or coniferous forest. And then again, ET type of climate will experience little bit of vegetation because of moisture stress again in these regions, since for most of the parts of the year they are covered with snow. So they will have little bit of vegetation in form of grasses, mosses, lichens, etc. And EF again will be devoid of vegetation because of soil being in complete permafrost state and these areas being covered by snow for the entire year. So this was all about Koppens classification in a glimpse. Now coming to the evaluation of Koppens climatic classification. It is true that Koppens climatic classification was one of the initial most effort to classify climates. So definitely it has certain merits as well as demerits also. And Koppen throughout his life kept on revising the scheme and modifying it to suit the real world situations. So one of the significant merit of Koppen's classification was that it was quantitative in nature. It used the temperature and precipitation variables, temperature and precipitation data, and analyzed and then matched it with the Candoll's vegetation pattern, which made it easier to understand and measure. And it used only two variables, which were temperature and precipitation. So he kept it simple by taking only two variables. And he paid due consideration to loss of moisture, and he also considered the effective precipitation in his later on modifications, where he gave importance to effective precipitation also. So the correlation of the Koppen's climatic region with the existing vegetative patterns was very much appealing to the geographer, as it recognizes the very evident association between the vegetation types across regions and climatic types. So the resemblance between the vegetation types and the climatic regions was a very positive aspect of Koppen's classification, because anybody could easily visualize it, remember it, and it was easier for any person to understand. And he gave due importance to effective precipitation also, although the concept of effective precipitation was added later on in later modifications of Koppen, but he gave effective precipitation importance in his later modified scheme. And finally, his model was descriptive, it was generalized, and it was simple to understand, and therefore it could be understood by any person who was trying to understand the climate of the region. And whether that person was directly from physical sciences or not, it was visually understandable, since world map corresponding to the vegetation types was available for the Koppen's climatic classification. So it was easier to identify, easier to visualize, and to understand. Now, there were certain demerits of Koppen's classification also, which he subsequently kept on revising and improving until its death in 1940s. So it was empirical and descriptive in nature and showcased perfect fit between vegetative types and climate, but limited in establishing the cause and effect relationship. So it was not able to establish the cause and effect relationship between the various elements, various factors which were leading for that particular climate to occur in that particular region. And the second important demerit was that although it provided a broad overview of the entire world and gave the climatic classification of the entire world in a very generalized way, it was very difficult to compare two or more small regions, because for the regional level, the Koppen's climatic classification was very variable, was not similar for the smaller regions. So later on, various versions of Koppen climate classification came to show the regional variations. He gave importance to only two weather elements. So utmost importance was given to only two variables, temperature and precipitation, while he was classifying the climates. And he neglected other elements like precipitation intensity, cloudiness, temperature extremes, winds, and air masses. So these are also important factors when we classify climates, but he took only two variables in order to simplify his scheme. But it was being criticized on the grounds that he kept it too simple and almost overgeneralized the climatic classification. And even when he considered temperature and precipitation as the two important climate defining elements in his classification, due importance and proper weight were not given to temperature and precipitation equally. While most of the primary climatic divisions, that is A, C, D, E, they were based on temperature. However, while classifying the B type of climate, the due importance was not given to temperature in this particular category, and precipitation was given much more importance in defining the category B instead of temperature. So although the primary classification categorization was based on temperature, but for B category, the more importance was given to the precipitation variable. So even the two variables he took were not properly weighted in his particular scheme. So he revised again and again his particular scheme and added symbols and criterias for different regions, which made the scheme difficult to memorize later on. So initially the 5 categories were given A, B, C, D, E, and later on other categories and subcategories and sub-symbols were added to reclassify the climatic classification and to make it more appropriate. However, with time, it made it more difficult to memorize since numerous subcategories were added to the scheme. Certain categories were overgeneralized. For example, ET, as we have learned in the earlier slide also, that ET initially represented the temperature of the cold climates of the earth, which included the cold climates of the polar areas also and cold climates which are found in the higher altitudinal regions of the lower latitude also. But it was only later on that H type of category was added to differentiate between cold regions of the polar areas and cold regions other than the polar areas, specifically in the lower latitudes. So there were problems in this particular aspect also. So certain categories were too generalized when the Koppen published his first work in 1900s. However, considering his lacunas in his earlier classification scheme, he subsequently improved and kept on modifying his classification scheme between 1918 to 1943 until his death in 1940s, and managed to overcome most of his lacuna, but his original classification remains his major contribution in climatology. So today Koppen's work is seen as classical work based on the empirical relationship between climate and vegetation, and this classification provides an efficient way to describe climate conditions defined by temperature and precipitation and their seasonality with a single metric scheme. And because climatic conditions identified by the Koppens classification are ecologically relevant, it has been widely used to map the geographical distribution of long-term climate and associated ecosystem conditions also. So there has been wider application of Koppens climatic scheme today after so many years when it was initially presented. So over the time period, other climatologists have modified portions of Koppen's procedure on the basis of their experience in the various parts of the world and have reclassified and remodified Koppen's scheme. Today, taking base of Koppen climatic classification, advanced modifications to Koppen's climatic scheme have been prepared by his predecessors, trying to improve the accuracy of the model to represent the actual climatic regions even at the micro level and even at the regional level, bifurcating the 5 main types of climatic region into various subcategories to better represent the real world scenario. So today the modification by Koppen and others, notably Rudolf Geiger between 1920s and 60s, updated his original 5 categories and added a special category which is H category along with 14 individual climate types and 24 subtypes. So over the time period, it has been modified numerous times. The modified open climate classification system is the most widely used system for classifying the world climates. And the modified version is also sometimes called as Koppen-Geiger climate classification system, which has 24 subcategories, 14 climate types, and 6 broad climatic regions, including the H category, which is the highland category. So A, B, C, D, E, and the highland category is being added later on. The modified version have 5 major climate categories, 14 individual climate types, and 24 subcategories. And much of the modification came from his predecessors also, which is today called as Koppen-Geiger climatic classification system. And it has been widely mapped with all the 24 subclasses provided in the Koppen-Geiger classification scheme. Besides Koppen, there were other geographers who also presented climatic classification, and one of the most prominent climate classification came from American geographer and climatologist Thornthwaite, who presented his climate classification in 1931, and subsequently modified version was presented by him in 1948. So initially Thornthwaite, just like Koppen, also presented his empirical scheme, and he believed that vegetation is the best indicator of climate of a particular region. So initially he divided climates based on 5 vegetation characteristics. First is the rainforest, then forest, third is the grassland, fourth is the steppe, and fifth is the desert. So based on these 5 initial vegetation characteristics, he presented his climatic classification of the world and divided the world climate into 5 major categories: capital letter A, B, C, D, and E, just like Koppen, although the meaning of these symbols were entirely different from what Koppen presented, where A represented wet or perhumid climate, B humid climate, C moist subhumid climate, D dry subhumid climate, and E represented arid climate, unlike Koppen, who symbolized E for the polar type of climate. So E in Thornthwaite's climatic classification represented arid type of climate and corresponds to desert type of vegetation. But later on in 1948, he completely revised his scheme and developed complex mathematical model based on the 4 indices. First, moisture index, second, the aridity and humidity index, third, the thermal efficiency index or the annual potential evapotranspiration, and fourth one is the summer concentration of thermal efficiency. So based on these 4 indices, he developed a complex mathematical model to categorize climatic regions. And based on this mathematical model, he was able to identify 120 climatic regions. However, in real world setting, he was only able to identify 32 climatic regions, which later on he marked and he identified in his scheme. So you can see that although Thornthwaite's model was much more rational in nature, and it is frequently cited as an improved climate classification system for its rational approach, but it is too complex to understand and therefore it is not frequently used in everyday settings. So even it was much more rational, it presented a better picture of reality. However, it was difficult to understand. Therefore, even till date, the Koppens classification is only preferred over the Thornthwaite's classification in most of the parts of the world. So very briefly, we have discussed the Thornthwaite's classification, and we will not go into the details of what is moisture index, aridity, or humidity index. I just wanted to show you the difference in how, in general, briefly, Thornthwaite's model was different from Koppens' model. So the basis of Thornthwaite's model was the precipitation effectiveness and thermal efficiency. So these 2 concepts were precisely developed by Thornthwaite later on, and based on precipitation effectiveness and thermal efficiency, he was able to categorize the climatic regions of the world and did not consider mere vegetation to be the indicator of climate. Besides this, he also gave a very important concept of potential evapotranspiration. So this concept of potential evapotranspiration was also given by Thornthwaite in his particular scheme. So his concept of potential evapotranspiration, precipitation effectiveness, and thermal efficiency are considered to be very landmark concepts in understanding the global climatic types. But we will not go into much of the details of the Thornthwaite's classification. It is just here to give you a brief glimpse of what Thornthwaite's classification was and how it was different from Koppens' classification, and why even it was so rational in its approach, the Koppens' classification is still preferred over Thornthwaite's classification. Now, besides Thornthwaite, other important classification was given by, again, American geographer G.T. Trewartha in 1966. But basically, his climate classification was the modified version or advanced modified version of Koppen-Geiger climatic scheme only, which is also known as Koppen-Trewartha climate classification, or simply the Trewartha climate classification. It is a modified version of Koppen-Geiger climatic scheme created to answer some of the deficiencies which the scheme was not able to explain, particularly with the climatic regions of the middle latitude extending between the 30 to 50 or 55-degree latitudes. The Koppen-Geiger scheme was not able to define most of the smaller microclimatic regions. So Trewartha basically attempted to redefine the climate of the middle latitudes to be closer to vegetation zoning and genetic climate system. So it was considered more true or real world reflection of the global climate. So it kind of modified and presented advanced version only of Koppen-Geiger climatic system with particular reference to C and D group and their subclasses, which were regrouped to accommodate regional climate variations in the middle latitudes particularly. So his particular classification presented 6 groups of climate, and again the English alphabet capital letters were used to denote the climate types, where group A represented tropical climate, B represented dry climate, C represented subtropical climate, D represented temperate and continental climates, E represented boreal climate, F group represented polar climates, and a separate category was also presented to reflect the snow-covered regions of the lower and middle latitudes, which was shown by letter H. So this was the 6 climatic regions which were given by Trewartha later on. So you can see that Trewartha's scheme was much more extension of the Koppen-Geiger climatic system and presented much more realistic picture. It was kind of a hybrid, where at one point of time it was closer to vegetation zonings also and genetic climatic systems also. So it was better reflecting the real world climatic conditions. So we will not go into the detail of Trewartha's classification also. It was just a brief to get you an overview of what was Trewartha's classification. So besides Koppen, Trewartha's classification and Thornthwaite's classification are most important when we talk about climate classification schemes. Summarizing the video now, German climatologist Vladimir Koppen presented his descriptive scheme of classifying world climates in 1900s and subsequently revised his scheme several times to better present the reality until his death in 1940s. So based on vegetation zones of the world which were given by D. Candolle and considering the temperature and precipitation variables, he gave 5 major climate types of the world and denoted each with English capital letter A, B, C, D and E, where A type of climate denoted the tropical moist climate, B was symbolic to dry climates, C represented moist subtropical mid-latitudinal climate, and D represented moist continental mid-latitudinal climate, and finally E represented the polar climates. But later on, after several revisions, H category have also been added to denote the cold areas of lower latitude due to elevation. So snow-clad areas of the lower latitudes fall under the H category, which was prepared later on. So all the major types were further divided, and this primary classification according to Koppen was based on the temperature conditions. He also gave the secondary classification of these major climate types and further subdivided each climate type based on precipitation and denoted them with several small alphabet letters. And in certain cases, he also presented a third category classification also. So altogether, he gave 5 major and 14 minor climatic categories of the world. However, there were certain lacunas in his work as he took only 2 climate categorizing elements, that is the temperature and precipitation, to categorize the global climates. So there were criticisms of overgeneralization. However, till date, his model remains one of the most simplistic and easy to understand climate categorization of the world. So his model was although descriptive, but it was empirical in nature, so it was easy to understand, and it has a strong correlation with the vegetation patterns of the world, which actually appealed many people, and it was very easy to understand. Although later on, other climatologists like Thornthwaite and Trewartha gave their classification also, and they gave genetic classification later on, which is much more accurate. But the Thornthwaite's classification scheme was complex. Therefore, Koppen's classification scheme till date only is preferred in understanding the global climatic regions of the world. So Koppen's classification, though descriptive in nature, coincides with the vegetative patterns which appeal more geographers, and it is easy to understand. Therefore, till date, Koppen's classification scheme remains most widely acclaimed model of climate classification schemes around the world, and his scheme of climate classification improves our understanding of diverse climate systems, biomes across regions, and his original works remains as one of the most acknowledged classical contributions in the field of climatology. So his scheme to date is used widely to study the climate patterns, climate types, climate categories around the world. Although several modifications and advanced modifications have been presented with time to accommodate regional variations and to make it more representative of the real world climate conditions. So with this, we have come to an end of the video lecture series on climatology. This particular module, that is module 7, was last in the series, and we have already covered the 6 other modules discussing various important concepts of climatology. So I hope the video lecture series will help you understand important topics, relevant concepts of climatology, and will help you understand how these concepts are associated with other fields of geography also, like physical geography and human geography also. And it will help you apply these important concepts in understanding the current issues and challenges of climate change, of global warming, and will help you understand the existing challenge of global climate crisis. So I hope the video lecture series are going to be very beneficial for you. Thank you for your patient listening. Thank you again.